Assalamu alaikum. Today's our topic is cross drainage structure. In this lecture, we are going to study cross drainage structure, its purpose, types, aqueduct, siphon, level crossing. In this whole series for aqueduct and its design, you can find the link in description for that. While other 5 things we are going to study in this lecture. So our first topic is what is cross drainage structure. So cross drainage works is a structure constructed where there is a crossing of canal and natural drain to prevent the drain water from mixing into canal. Well, in this line there is a canal, there is a crossing of canal and natural drain. There is a crossing of canal and natural drain. Whenever there is a crossing of two water lines, for example, this is one water line flowing in this direction and this is another flowing in this direction, there is a cross section, and at this point we provide a cross drainage structure. For its practical approach, we can see this picture. This is a cross drainage structure. Look at this. These are ports. These are either going in this direction or this, but these are flowing, and you can also see this. So this is a practical example of a cross drainage structure. If we have another picture, we can see this. This is an example of aqueduct. What is aqueduct? We are going to learn soon, and in the exams we can draw a picture just like this. That will help to impress examiner. A cross section, if we will draw, what is a cross section initially? So a cross section is just a cutting section. If we cut this line from this portion and we wash this from this side, a cutting section, we can see a structure like this simply. Now this was the lower structure, okay, and this was the up, from where the boats were coming out and down. So this is our cross drainage structure. So what is a cross drainage structure? It is a crossing of canal and natural drain. Crossing of canal and natural drain to prevent drain from mixing into canal. Now what are its purposes of providing a cross drainage work? So I have googled this, then the purpose of cross drainage work, I find out these, but I have resolved all these 3 big points in these 3 sum up points. The first point tells us continuous flow. To understand this, for example, we have this river that is flowing in this direction. We have a lot of farms here. For example, these are farms. We need to provide a water courses, irrigation water there. These are its water courses. So for example, we provide a canal here in this direction. These water courses can get water from here. Now let's suppose there are chances that in this direction there must be some sort of natural drain that is flowing in this direction, or there are chances that in this direction might be flowing, or even in this direction coming from this side, just flowing in this direction. So there are chances that in these areas there must be a cross drainage work so that the canal and drain might cross each other. So now this is the canal's continuous flow. Now this continuous flow, for the canal to have a continuous flow, we provide a cross drainage structure. As there is obstruction, as we can also read this over here, the watershed canals do not cross natural drainage. Now this is an ideal condition. The watershed canal do not cross drainage, but in actual orientation of the canal network, this ideal condition may not be available, and the obstacles like natural drainage may be present across the canal, as we have given an example here. So the cross drainage works must be provided for running of the irrigation system or for a continuous flow of irrigation system. The second point tell us that prevent from mixing. Now we can actually see this, that the drainage water is coming. There are chances that these both will meet at this point. So to prevent it from mixing, it is the same point is written in about 3 or 4 lines. At the crossing point, the water of the canal and the drainage intermix, so for the smooth running of canal with its design discharge, the cross drainage works are required. Same simple thing. And the third point is prevent from diverting. Now what is meant by this prevent from diverting? To understand this, it is quite simple. Now for example, prevent from diverting, as we know that there is a drainage, okay, so there are chances that when this water come across, this either flow in this direction or in this direction. Why? Because there is a drainage, it can flow with it, but what is its natural flow? It should flow in this direction, as we have to provide irrigation water towards farms. So to prevent from diverting in either direction, so the same line is written in more words. The side condition of a crossing point may be such that without any suitable structure, the water of the canal and drainage may not be diverted to their natural direction. So the cross drainage work must be provided to maintain the natural drainage of flow. Okay, so these 3 points, cross drainage structure is to provide so that the irrigation water can continuously flow, and it also prevent the canal water from mixing with drainage water. It also prevent from diverting against its natural flow. So we have learned what is drainage structure, purpose of drainage structure, these were now types. Now there are 3 types of cross drainage structure. Either the canal is over the drainage line, and for example this is I am showing a level of bed level of canal, okay, and this is full supply level of canal, okay. Now for example drainage level is here, okay, this is my drainage level, full supply level and bed level. So in this case the bed level of canal and full supply are above the drainage line. So in this case the canal is crossing over the drainage line. In this case we provide an aqueduct usually, or a structure which crosses over the drainage is called known as aqueduct. It's more types and it's more understanding, and it's for its problem. Watch the video, the link is in description. Now second type is under a drainage line. When canal crosses under a drainage line, for example this is canal, and if this crosses under drainage line, now for example now this is my full supply level of drainage, okay, this is drainage, full supply level and bed level. Now for example my this is my canal and it is crossing below the drainage line. In this condition, the structure which helps the canal to cross under a drainage line is known as siphon, Siphon, okay. Now this is siphon. There is also a third condition when both the canal and the drainage line crosses each other at the same level. Now this is the top view, okay. I have shown you these are the side view. If both the canal and drainage are at the same level, we provide level crossing. Now we will learn about siphon and level crossing. For example, now we have also done this. Its types. Now it's time for siphon and its design. Now what actually is siphon? There are actually two types of siphon, okay, or two types of canal crossing under a drainage line. The first is known as super passage. Super passage. And the second is known as simply siphon. SIPHON. Now when super passage is provided and when siphon is provided, it is quite simple. Just understand from this figure. Now for example, I will take a general example. For example, if I cut this figure cross section, if I cut this water from here and I can watch this from this side, what will I see? I will or we will see canal and drainage. Okay, we will see a canal and drainage. Now for example, there is a canal drainage line. Initially we will draw a drainage line. For example, this is the drainage line and this is the canal line. Okay, now I knew that this is my drainage line and this is my canal line. Okay, now this is the bed level of canal. This is the full supply level of canal. This is the full supply, and no, this is the, oh, I have done a blunder here. This is the bed level of drainage. Okay, bed level of drainage, and bed level of canal is here. Now, like in this condition, we provide super passage. What does that mean? It simply means if the bed level of drainage is above the full supply level of canal, then we provide a super passage. But if the full supply level means this level, full supply level is here, means above the bed level of drainage, we provide siphon. Simple. If full supply level is below the bed level of drainage, we provide super passage. If full supply level above the bed level of drainage, we provide siphon. Okay, these are the two types of super passage cross drainage structure under the canal crossing under the drainage. Okay, these are the two types. And about their design, if we are designing the super passage, it is just like a trough. What is a trough? A trough is a V-shaped cross-sectional structure above which water passes, and just like a pipe, an open pipe. So whenever a super passage is provided for a drainage line to pass the water, it does not require any type of more safety or etc., because drainage water is a lot lesser than the canal. So a simple pipe is provided so that the water can pass, or a simple trough with it's always economical. So its designing is just not very much important. Simple structure can be very simple, and low maintenance structure can be provided for a super passage, just like a pipeline. But when it's come to the design of siphon, we have to make sure everything, because this might be a lot of costly and we have to make it a safer. So we are going to learn the designing of siphon. So for this case we have a problem. This is a problem of a past paper, civil commission past paper, design of hydraulic structure. Now it is written here: a canal is crossing under a siphon conditions. Design the following data. Now this is the stream and this is canal. Now in these questions we have already been told canal crossing a stream under a siphon conditions. Okay, design a siphon. Now we know that canal is crossing through siphon, and it should be under stream, as it is given that there is a stream. So this thing is already given, but if we are not given, how we will find out? It's quite simple. Initially we are given, we will check out our canal, the data for our canal. Okay, for example, now in the here we are given the bed level of canal as 474.70. so we will draw, for example, this is my bed level of canal, and it is 474.7. now what is the full supply level of canal? Now it is given that full supply depth is given. If I add this depth with this, I can get my full supply depth of canal is equal to 474.7 plus 1.3 is equal to 476. So it is 476, and it is full supply level of canal 476. Now I will check out the stream, the bed level of a stream. So the bed level of stream, actually the highest flood level of a stream is given, and it is 475.8. I know that highest level. Now 475.5, it comes here. The 475.5 comes here. Now it is 475.58, and it is full supply level of stream. So I come to know that my full supply level of stream is above the bed level of canal. So we are supposed to provide a siphon so that this canal can pass out, because it is given in the question. So all we have learned here, we are going to write the same thing but in a different manner. For example, we are supposed to write this. Okay, so for this our solution. Now we knew that our full supply level of canal or full supply level of stream is, we knew that our full supply level of stream is greater than bed level of canal, and its difference is, what is the difference? We knew that we will just need to subtract these both. We can get about 0.88 meter. 0.88 meter. So this is the difference of these both. Now we can write it here. Canal will cross stream through siphon. Canal will cross stream through Siphon, Siphon. If I am pronouncing bad, you can always check that out. Now after we have written that, now we need to understand one thing here. We need to find out the length of siphon. We are designing this siphon. Now what is actually siphon? Siphon is just like it is a barrel. Now to understand barrel, suppose a pipeline is passing underground. A pipeline is just like of cross section this. A barrel just look like this one. It's a barrel. It's a square rectangular shape. Just like the concept is just like a pipe. So this barrel. So initially we need to find out its length. To get through, what will be its length? It's quite simple. For example, this is our canal. For a top view, we can see that this is a stream, and this is canal. Canal is crossing under the stream. If we can watch this figure from here, we can knew that this is my stream. Okay, so this is now this is the siphon. our siphon will be like this. If we can watch this from this side, it will show like this. Now it is the length of siphon. This one is the length of siphon. Now this length is equal to the width of stream. Okay, now this is siphon. I am denoting siphon with P and stream with S. Now for the length of siphon, I knew that I need width plus this length and this length. Okay, and we usually design the siphon for worst conditions. So for length of siphon, we knew that the width of stream and width of stream is given here as 30 meter. So 30, and for worst condition we knew that we will take 10% more. So 1 plus 0.1, 1.1 plus, now this triangular portion will be about 15 meter, and it is from both sides, so multiply by 2, so it will be 63 meter, and it is length of siphon. For discharge of siphon, we have, I knew that from the, what is the discharge of canal, it is 2.5, it is 2.5, so 2.5 into 1.1, 10% more, as we are designing for worst conditions, so it will be 2.75 cubics or 2.75 cubics or cubic meter per second. Now the velocity of siphon. For velocity, we take a minimum value of 2.44. We can also take about 4 meter per second, 2.44 meter per second. But if our area comes more, now we knew that we can get this area is equal to discharge per unit velocity, and we knew that our discharge per unit velocity means these two, it will make about 1.02 meter square, and I knew that our cross section will be like this. If I can square root this area, I will get this one side is equal to 1.01 meter and 1.01 meter. So this is what our barrel look likes, and this is its side. And for example, if we have got about a greater, this is 1 meter, 1.01. If we have got this length about 4, 5, 6 meter, we have increased the velocity so that our this side comes a little lesser. Okay, so this was just the dimensions. Now I have already shown you this shape. Okay, now this cross drainage structure is shifted from this point to about this point. So how much depth will be this? This is due to the scoring depth. Scoring means the water crossing this stream will actually touch the siphon if the siphon was here. Okay, so this will score it. So that's why we are providing this depression about this depth. So how much depth will we provide? It will be find out by the scoring action. Now how much score it can do for the scoring depth, we will find out due to the action of this stream. Okay, so using our Lacy's formula, for score is, I will give the heading here, we are finding score as SCOUR. Our score is equal to, for the score, we are finding score. Okay, for this our formula is R is equal to 1.35 q square by f whole power 1 by 3. Now this is the formula. F is the lazy cell factor and it is equal to 1. Now what is Q? Q will be equal to discharge per unit width, and this is for the stream. And for stream, if we can go back towards our data for its discharge and depth, we can find out that discharge is 12.33 and width is 30 meter. So 12.33 divided by 30 meter, I got my answer equal to 0.344 cubic meter per second per meter. It is discharge per unit width, and I've got my Q, and I can find out my R using this formula, and I got my R directly as 1.105 meter. Okay, so now as we are designing for the worst conditions, so for this we have taken the score depth is equal to, we are taking this score depth means ds is equal to 2 times r, and this becomes 2 multiplied by 1.105 is equal to 2.21 meter. So we can say that barrel will be so that this shape will be the bed level. We can say that the siphon will be shifted about 2.21 meter below the bed level. Okay, so this was the complete concept of this design, but there is much more for it, and for this I am drawing this. Okay, now I will show you what we are going to find out. Okay, now for example, this is our siphon in this way. Okay, so there are chances that there will be losses, but we don't know how much losses will be there. What is mean by these losses? For example, this is the level of water when the water enters the siphon. The water enters the siphon from here, for example this point. Now the water enters the siphon and the water level is this. Okay, the water level is this. Now when the water leaves, for example water come across, it went in this direction, and it's when leaves, it is the depth is this. Okay, now the one is shown in red. For example, I can change its color. The one is shown in green. Now this is the water level when it leaves. So there are losses inside this siphon. What are all these losses? Now we will come across these losses. When the water enters, there are losses at the entrance. I will name it as I, the losses due to entrance or inlet. Okay, second losses are at this bend. Whenever there is a bend, in this bend there are losses, and this bend are on both sides. So the losses due to bends, two losses, I and B, inlet or entrance, and second is bend. Third loss is due to this friction at the surface, okay, and at the sides. So we are naming that third loss as resistance or friction. I will name it as F, means friction. And the fourth loss is at this exit. We can name it as X. X means exit. So there are a total of 4 losses. We will find out these 4 losses. Now what the formula for the first loss, that is I or inlet. The formula for inlet loss is 0.5 V square by 2G. Okay, now what is V? V is the velocity in the siphon, and it is how much we have assumed, 2.44. So we can actually get our answer here. Okay, so we get our answer. You can put all these values and you can get the answer, and I got my answer 0.15 meter. Now our second is friction losses. I denote it with F. F is equal to friction losses, and its formula is S into L. S and L. Okay, now L is the length of siphon. I can denote it as B, and S is the slope. Now to find out slope, I have formula V is equal to 1 over N R power 2 by 3 S power 1 by 2. Okay, V is the velocity, it is 2.44 meter per second as we assumed. N is equal to 0.014 for concrete, and R is equal to, now for R, if we have R we can find out our S, as we have everything. For R is equal to A over B. For barrel, A is equal to B into D, and for perimeter we have formula B plus 2 times D, and from where we can find out B and D. These are our B and D. This is B and this is D. Through area we find out D. Now coming back towards our question, if we have find out everything using all these values, I am directly putting my answer 0.47 meter. You can always solve this. I don't want to make this video a little bit larger, so I'm directly solving it. And my third loss is loss due to bends, means P, and it is equal to twice V square by 2G and F. Okay, now there is a factor F. Now this F has another formula. Okay, the formula of F is equal to sine square sigma by 2, the angle is sigma by 2, plus 2 sine power 4 sigma by 2. Okay, now how we will find out this sigma, what actually sigma is. Now at this transitions, due to these bends at the size, the friction losses, we knew that our side just look like this. To reduce the friction at these points, means at these, to reduce the friction due to these points, we provide a transition points, and these are known as transition points. Okay, so in the angle at this point is known as sigma, and this usually either is 5-1 or 3-1. What is mean 5-1 or 3-1? Like this, either this is 5 or 3 and this is 1. So whichever we take, most commonly we use this 5-1 side, and we find out this angle, and we knew that how we will find out angle. Tan pi is equal to perpendicular upon perpendicular is 1, and hypotenuse is perpendicular upon base. Perpendicular is 1 and base is 5, so 1 upon 5, and using this formula we can find out this one, and using this one we can find out our sigma, and my angle sigma and we can find out F actually if we have sigma. So you can always find out using calculator. I am also writing this value of F 0.0099992. It's 9. If I have F now, after I find out my F, I can find out the losses due to bend losses, bend losses due to bend, and my bend losses are equal to 0.0025 meter. Okay, we have actually calculated our 4 losses, and it's time for our 5th loss, and it is losses due to exit losses, and its formula is quite simple: 0.5 divided by 2g v square minus vt square. And for this I have to explain what is v and what is vt. Now v is velocity in barrel, BA double R, and what we have assumed, our assumed velocity in barrel is 2.44 meter per second, so that will be it. And Vt is velocity in canal. Yes, the velocity in canal. And what velocity in canal we have been given? We will check out here. Canal velocity is 0.58. So using this, velocity in canal, so using this we can find out our exit losses, and these are equal to x is equal to 0.05 meter. Okay, so these are all 4 losses. If I can calculate all these head losses, which I can show you it with different color, because the colorful makes it look better. H is equal to all these losses: inlet loss plus bend loss plus friction loss plus exit loss. If I add all these 4 losses, I got my answer is equal to 0.6725 meter answer. And now it's time to calculate my full supply level of canal on downstream side. What I mean by is that when the water leaves here, what will be this level? Full supply level at downstream side. This is downstream type, and its full supply level can be find out using the full supply level of siphon at downstream is equal to, now full supply level at upstream side, full supply level of siphon at upstream side minus total head losses. Okay, now we knew that our full supply level at upstream side is 476. We have already calculated here. Now where we have calculated this one, 476. Okay, 476 minus losses are 0.6725 is equal to, my answer is 475.33 meter. So this was the solution. I have taught you all the solution. I might have made a little bit of mistake in calculation, there are chances always. So this was the concept, and this is the way we can solve this question. It's quite simple. First we find out its length, dimension, and discharge etc, then all score depth and then losses. So this is the whole concept. What I have done, I might have made a mistake, but you should try to solve it using your calculator and try to make it exact. Okay, now we have also learned Siphon and its design. Okay, now it's time for level crossing. Now in level crossing, level crossing is a structure is provided when canal and drainage crosses at same level. When the bed level of canal and the drainage line are at the same level, the usual method to allow canal to cross drain is to mix water of canal with the water of rain and then to draw from it the canal's designed discharge from the other side of the drain. However, it is essential that the water of the drain is suitable for irrigation purpose. The works constructed to accomplish it are called level crossing. Okay, in this level crossing we actually mix this water, the drain water and the canal water are both mixed. Means if we can show you like this, just like a cross section of a chalk that we call. Now this is called, if this is canal, this is drain, these are mixing here, all water molecules are mixing here, but make sure that this drain water should be suitable for irrigation purposes. And the structure made here is known as level crossing. A level crossing consists of 3 cross regulators. A level crossing consists of, now this is our level crossing, the shape we can see here in the red pen. It should be consist of 3 regulators, 2 across canal and 1 across drain. Now for example, this is my canal, there should be 2 regulators across canal. It means canal number 1, 2 regulators across canal in the purple line. I have shown this in the purple line, and 1 across drain. For example, this is my drain, so I have 1, so there should be 3 regulators, 2 across canal and 1 across drainage in a level crossing. When the drain is not running, for example, when the drain water, now this is my drain water, when the drain water is not running, the canal falls in the drain. Now for example, this is canal, there is water in the canal, in the drain, but it is not flowing. Then we open these regulators, the canal regulators. The grades of the cross regulators across the drain are manipulated in such a way to allow the canal regulator to draw its designed discharge at that point at the required level. For example, these are opened. For example, this becomes a shape like this. When these are open, this becomes a shape like this, and the water in the drain and the canal is mixed, and this water is flown in the required direction, and the design discharge is got in this direction. Okay, when the canal drainage line is stopped. Okay, but when the drain is in flood, means drain is flooded and it's flowing, the canal regulators are kept close. Now if it is flowing, the drainage is flooded and it is flowing, the canal regulators are kept close and the drain regulator is fully open. This canal will be kept closed using its 2 regulators, and this will be opened. Okay, and this won't be closed and this will be open. Now for example, it was in this direction, now it is opened. Okay, so this is opened and drainage is going in its flow. The drain regulator is kept fully open till the sediment laden flooded discharge passes downstream. The sediment laden is passed towards downstream in the drainage, and water becomes clear in the stream. And when the water becomes clear in the stream, the canal regulators are again open, and the design discharge for the canal is taken again from the other side of the canal. Another important factor is that only water from the drain should be allowed to enter the canal whose quality is suitable for the purpose of canal water. Otherwise, another type of cross drainage structure should be used. So it is quite understood. Okay, now in this lecture we have actually covered everything, even the level crossing also. Now I am actually adding another point here that might come in the commission paper. Selection the type of cross drainage structure. When we will provide which type of structure: aqueduct, siphon, super passage, simple siphon, level crossing, etc. For this I can tell you about this. Now for example, there are a total of 5 conditions. These are quite simple and quite understandable. Okay, condition number 1: when the bed level of the canal is sufficiently above the highest flood level of the drain, an aqueduct is constructed. It's quite simple. Now the canal is crossing at this level and the drainage is this level. Now this is the highest flood level of drainage. Okay, highest flood level of drainage, and this is the bed level of canal. So the bed level of canal is above the highest flood level of canal, so we will provide a simple aqueduct. Okay, we will provide a simple aqueduct. In second case, now this bed level of canal means this one. Now this is bed level. Now this bed level of canal is here, and the drainage lines means highest flood level of drainage is here and the bed level of drainage is here. Highest flood level of drainage, bed level of drainage, and highest flood level of or bed level of canal is here. In this condition we provide a siphon aqueduct. Okay, simple aqueduct, siphon aqueduct. In simple aqueduct we have already, in the link in description will tell you how to construct a simple aqueduct. In a siphon aqueduct, it is the design of a siphon. Quite a simple siphon is designed and it crosses like in this direction. Okay, so these were our 2 cases. In third case, now this drainage is above and canal is below. So this drainage is, it is canal and it is drainage. So the drainage will pass the from above the canal, and the canal will pass below the drainage, and in this condition we provide us super passage. Super passage. The construction of super passage is simple, like a pipeline passing over a water level. Quite simple. In fourth case, in fourth case I can say that when the full supply level of a canal is above the bed level of drain. Now for example, this is the drain level. Now full supply level of canal is here. This is full supply level of canal. In this condition we provide a siphon. A siphon is just like this. Else canal will be constructed like this. It's quite simple. In the fifth case, the drainage is here at the same level and the siphon is at the same level. So a level crossing will be provided. So this is the selection of the type of cross drainage structure. If you haven't understood this completely, replay this part again. If you have understood anything from this video, subscribe and share this video. Thank you.